All right, team, go ahead and print out the notes for day 25, section 11.3 slope, and take a look at the warm-up here. So you're going to see in front of you just a grid with some points plotted. And the first thing I want you to do is just create a table of values for the points that you see. I'm going to set up an XY chart here, and I'm just going to go in order from left to right here. So this point down here is going to be my first one. The x coordinate is -2 and the y coordinate is 0. The purple point now is going to be at, looks like -1. Notice that's halfway in between, and then +1. And then this black point, it would be my y-intercept. So my x coordinate is 0, my y coordinate is 0. The red one is at +1 and 3. And the blue one over here is at +2, 4. Now, what I want you to do is I want you to go ahead and follow the pattern, and I want you to add 5 more points that follow this pattern. They can be anywhere you want on the graph. I'm going to put a point right here in between, maybe one right up here, here, and there. Now, if you wanted to, you could actually just keep going. I could keep putting points in between all of the spaces, and notice what's happening here. We are getting a straight line. What I want you to do next is go ahead and find the x and y intercepts, and I want you to write them as an ordered pair as well as identify them. All right, here's what I found for the x-intercept. The x-intercept is going to be where it touches the x-axis, and it touches the x-axis right there. So that's going to be the point -2, 0. The y-intercept is where it touches the y-axis, and it looks like this point right here. So x is 2, x is 0 and y is +2. Now, I want you to try to describe the pattern that you see. So if I clean up my screen, and I'm going to look at the pattern, it looks like from one point to the next, I'm actually going up 1 entire unit, because remember, this is where +1 is, because each little half, or each tick mark right here is represented with a half, and I'm actually going over 1. So my pattern would be up 1, right 1. Awesome. All right, let's move on to the lesson. So what I want you to do is for each of the tables below, I want you to answer the following questions. I want you to describe how the y values are changing for number 1. Number 2, I want you to tell me how the x values are changing. Number 3, I want you to write a ratio of how y is changing compared to how x is changing. And then the fourth one is kind of the extension piece. And I want you to follow each pattern and tell me what y will be when the x value is 0. So for example, let's walk through the first table together. So for number 1, you're going to be telling me how the y values are changing. I'm just going to be looking at my table, and as I look down the table, it looks like from each step in the table, I'm going down by 1 unit. So my y's are changing. I'm going to do a really cool math symbol here, and I'm going to do a little triangle y, and I'm going to say -1. That little triangle is the Greek letter delta. So I would actually read this as delta y. This is just for you cool math nerds who want to know this little extra information here. And what delta means is this is another way, a fancy way to say change in y, is what that's saying. So there's number 1. For number 2, let's look at how the x values are changing. So I'm going to go back to my table, and I'm just going to look down the table. From -4 to -2, it looks like we went up by +2. -2 to 0, we went up by 2 again. And it looks like as I follow down this table, every time I go down a step, my x's are changing by +2. So I'm going to say my delta x is going to be +2. So that means my x's are changing by +2. Now, for number 3, when we write the ratio of how y is changing compared to how x is changing, well, y is changing by -1 when x is changing by 2. Remember, ratio means you are just writing a fraction. You are comparing two values. Now, for number 4, what I'm going to do is I'm going to look at the table, and if it tells me what y is when x is 0, then great. I don't have to work very hard. But if it doesn't, we'll have to figure it out. If I look here in my table, I can see that y is 11 when x is 0. So I'm just going to write that as an ordered pair. When x is 0, y is 11. All right, I want you to try the next 3 on your own. I will go ahead and write my key in, but you can pause the video here and then you can check and see how you did. Ooh, notice this one, it doesn't tell me what the y value is when x is 0, so I'm going to have to work backwards in my pattern. So if I go backwards 3, that means I would also need to go backwards 4. So from -2 going backwards would be, oops, oh, I touched something, would be -6. And then I need to go backwards one more time. From 3, I'm going to go backwards 3 again to get to 0. And then from -6, I'm going to go backwards 4 to get -10. So that one made me work pretty hard. So then I can write when x is 0, y is going to be -10. I'll write my key for letter C now. So my ratio here is -4/1. I could simplify that if I wanted to and say -4. And this one's really nice because it tells me when x is 0, y is +9. All right, let's look at the last one. This is a really small table. This one might make me work a little bit. So my delta y, my change in y, looks like it's just going up by 1. And my change in x looks like it's going up by 10. This ratio is going to be fine to write. It'll just be 1/10. But what's going to be a little bit tricky is I'm going to have to work with this table to try to figure out what y will be when x is 0. So I might just follow the pattern of counting by 10. So there's 50, 40, 30, 20, 10, 0 if I work backwards in the x table. And now working backwards in the y table, this means I need to go backwards 1. And it looks like when x is 0, sorry it's a little scrunched in there, my y value is going to be +1. Awesome. You pretty much just did everything you needed to do with slope. All right. Let's take a little break here and let's look at this next part. And what I want you to do is I have a slope and I have a point, and I want you to plot this given information. So if I know the slope is going to be a -1/3, that tells me the line is going to be going up and to the left. So I'm expecting it to go in that direction. And my point is going to be the point 4, 2. So I actually need to start with the point first. So there's my point, x is 4, y is 2, so that's going to put me in the first quadrant over there. Now, for my slope, I'm going to go up 1. The slope is actually my pattern. So every time we've been talking about what's the pattern, you've actually been identifying the slope. So I'm going to go up 1/3 in the negative direction. So I'm just putting those little dots on there just to help me count, and I might just apply a couple more. So up 1/3 in the negative direction. and it looks like my points are falling in a nice pretty line. Notice I could also go down 1 and to the right 3. That's still going to make it so my line goes up and to the left. And then I'm going to go ahead and play connect the dots. Let's try one more. Here my pattern or my slope is going to be 2, and then I'm going to have the 0.05. So I'm going to start with what I know. I need a starting point, so that's going to be the 0.05. So when x is 0, y is 5. Now my slope is 2. Notice it's positive, so I'm expecting that line to go up and to the right. And what's a little tricky here is the fact that I only have one number. So when I'm trying to continue on with this pattern, I only have one value. So it might be really helpful to write 2 as a ratio of 2 values. So 2 over 1 is actually my slope. So that tells me I can go up 2 over 1 in the positive direction. So up 2 over 1. Notice I can also go down 2 and to the left 1, and that helps me follow that same pattern. I've got a positive slope. All right, on the back side of this sheet, I have 2 examples, and I want you to look at these 2 lines. And I want you to be able to figure out what is the slope of each of these lines, and then I just want you to kind of compare and contrast each pair. So for example, I'm going to look at this purple line, and I'm going to start with 2 points. And I'm looking for lattice points. So lattice points are points that are really easy for me to find because they fall exactly on the grid. So I'm going to pick those 2. You could have picked any combination of the 3 points that are given on that purple line. So if I look here, I'm going to count how many I have to go up. 1, 2, 3, 4, 5, 6. So that means my change in y is 6, and my change in x is 2 units. And notice we had to go to the left to help us determine it. So we'll make some notes over here. So my purple line, we went up 6. My change in y was 6, and my change in x was -2. Now I could simplify that and get -3. And just to kind of verify, you can make sure that that pattern holds. So let's go for maybe 1 point to the next. If I go up 1, 2, 3, and over 1, I actually hit a really nice point there, and I could keep going up 1, 2, 3, left 1 in that negative direction, and I hit more points on my line. So I feel very confident that the slope of that purple line is going to be -3. So let's take a look at the black line. So with the black line, again, I'm going to pick 2 points. I'll just pick the green one and the blue one, and I'm going to count up. I'm going to go up 1, 2, 3, 4, 5, 6. So my change in y is 6 units, and my change in x looks like I went -2 again because I did 2 units to the left. And -6 divided by -2 is -3. So that's going to give me what I'm going to call the slope of that black line to be -3. And notice we can kind of verify again. I can go up 3 to the left 1, up 3 to the left 1, and I'm hitting points that fall on this graph. So for the last part of this problem, notice it says compare and contrast. So what do you notice about the 2 slopes of these lines? Well, they actually are the exact same thing. Both lines are -3 for their slope. And if you also just kind of notice by visually inspecting these lines, the slopes or the lines themselves are actually parallel to each other. So we'll just say the slopes are the same and the lines are parallel. So keep that in mind. Looking at this last one here, again, I have a red line and a black line. So let's take a look at the red line, and let's find the slope of the red line. So I'm going to pick 2 points. Notice my points are not equally spaced out on here for the ones that are plotted. That's okay. I'm still going to pick 2 points. And so I'll pick down here, and I'll just make a little note off to the side here that I'm going to be working on the red line. And let's look again at that ratio of change in y to change in x. So I'm going up 1, 2, 3. So my y values changed by 3. My x values changed by, it looks like -2 in this case. Now 3 over negative 2 you could simplify as negative 1.5, but for our graphing purposes, we absolutely want to leave it as a reduced fraction, but also as an improper fraction. If you wanted to, you could maybe just clean up where you put that negative sign and either put it with the negative 3 or put it out front directly. It's just not the best math notation to have it in the denominator there. All right, so let's look at the other line. Let's go ahead and take a look at the black line, and I'm going to pick 2 points. So we'll just pick those first 2 right there. And let's find that change in y, and let's find that change in x. So it looks like y changes by 2 units, and x changes by 3 units. So we would say the slope of the black line is 2/3. Now, if the last pair of lines were parallel to each other, these lines are definitely not parallel because they're actually intersecting each other. They're touching, they cross. And it's kind of maybe not entirely obvious from the picture because it's not in there, but I might put a little box right there because these lines happen to be intersecting at a 90-degree angle. That means the 2 lines are perpendicular to each other. Now, if you take a look at the 2 slopes, we have one slope that's negative 3/2, and we have the other slope that is a positive 2/3. So if you notice, there's a special relationship happening between these 2 slopes. So when lines are perpendicular, they're going to have slopes that are opposite. So notice one is positive, one is negative, and then they are the reciprocal. Remember, the reciprocal means that the numerator and the denominator have switched places. So if the black line was 2/3 for this slope, the red line had a slope of negative 3/2. So opposite sign, and then we have the reciprocal. Numerators and denominators have switched places. All right, so let's write a summary here. So I realized I didn't really give you a formal definition of slope, and let's kind of do that now. So I want to start out with, there's 4 types of slopes that we can have. We've already seen a positive slope. And I'm just going to write here that a positive slope is just any slope that's going to be going up and to the right. And then we have a negative slope. So for example, that line would be a slope that is negative. It is a line that's going up and to the left. The other 2 kinds of slope that we haven't seen yet explicitly in terms of slope is going to be a flat line. This one would be a 0 slope, meaning there is no rise. If you look at the change in y between any 2 points right here, it's not going up any because it's flat. So this delta y would be 0, and our delta x would be however many units is. Let's just say that's going to be 1 unit. And 0 divided by any number, so in this case 1, is still going to give you 0. So this would be a 0 slope. And if you recall from the last lesson, something that has a that looks like this is a horizontal line. This is going to be a y equals line, or this is just going to be some kind of number. And then the 4th case is going to be a vertical line. This slope is actually considered undefined, because if we look at any 2 arbitrary points on this line, my change in y is whatever. Again, let's say that's just 1 unit right there. But my change in x now, notice you're not changing at all in the horizontal direction. So now my change in x is 0, and any number divided by 0 gives you a big old fat error on your calculator. So this is why you get an undefined answer. We cannot divide by 0 no matter how hard we try. And then recall again from that last lesson that whenever we have a vertical line, it's going to be x equals some number is what that equation is going to look like. So let's talk about these big slope ideas. There's lots of things that we can use as far as equations go. to represent slope and notation as well. So slope is often abbreviated with an M. So whenever you see that M, they're referring to slope. And we have lots of equations. So we can think about it as the change in y divided by the change in x. And I'll just write that out because that's what that delta is saying. Change in y divided by change in x. You might remember from your high school days, like slope is defined as rise over run. That's another nice way to help you memorize this. Rise meaning you're going up or down, and run meaning you're going either left or right. We do have a formal equation here, y2 minus y1 all over x2 minus x1. And I'll show you in this next one just how to use that formula, but that's something you can do as well. Also keep in mind, we did all of our slopes with tables, with XY tables, so you can find out what is the change in Y and what is the change in X in a table and set up that ratio. I do want to add one more thing here. Oh, it's not letting me extend the page here, so let me move on to the next page where the homework slide is. And I just want to make some notes. Parallel lines have the same slope, and perpendicular lines have slopes that are going to be opposite reciprocals of each other. So if we were in class, we would actually be doing a few examples here. So why don't we just do one more example and I'll kind of show you how you can do it either way. So I'm going to make up this example. We'll see what happens here with the values I choose. How about 10, negative 4, and the 0.53? So your directions for this would be find the slope. So you have some choices. If you wanted to set these up and just do the tables, there's your first point, x is 10 and y is negative 4. And the second point, x is 5, y is positive 3. You could go ahead and do that and then find your change in y over your change in x. So it looks like here my y values are changing by positive 7, where my x values are changing by, it looks like, negative 5. So you would say your slope for this one, your m would equal change in y over change in x. So this would be 7 over negative 5. And then we could just clean that up by moving the negative either with the 7 or out front. Now, if you want to play with the formula, if that's more your speed, I highly recommend labeling. So the first x that I see is going to be the 10. So I'm going to label that one x sub 1. So the sub means it's in the little subscript, so it's down below. And then the negative 4 is the first y coordinate that I see. And then with the 5, the 5 is the second x coordinate, and the 3 is my second y coordinate. So then I could plug into my slope formula, which is y2 minus y1 over x2 minus x1, and then I can just substitute in my numbers. y2 we've already identified as positive 3, y1 we've already identified as 10, and I've got the subtraction sign in there. My x2 is 5, and my x1 is 10. So I'm going to have 5 minus, oops, I think I have a wrong value in there. Sorry, my y1 is negative 4. Sorry about that. And then my x2 is 5 and my x1 is 10. So now I can clean this up. It looks like I'm adding the opposite here. So I'm subtracting a negative 4, so that means I'm really going to add a positive 4. And 3 plus 4 is 7. And 5 minus 10 is negative 5. So I'm getting the same slope here. I'm still getting a negative 7/5 for my slope. I hope this helps. We will have a quiz on Friday over 11.1, 11.2, and 11.3. I will also be hosting virtual office hours on Friday during our normal class time, and I will set up instructions on D2L. It'll be through WebEx, so you can download the app to your phone and we can have virtual office hours. I'll be able to work out problems for you and answer questions, and hopefully that should work out okay. Your homework for tonight is going to be through Connect Math. So go ahead and find Connect Math Homework 11.3. Email me or let me know if you have any questions, and take care.